Bismillah ar-Rahman ar-Rahim. In this video I'm going to talk about body fluids, which was the subject of lecture 9. I suggest you that to read this subject from Guyton book. It's chapter 25. In the first lecture on this topic we talked about fluid intake and output, compartments of body fluid and measurement of fluid volume. So let's begin by fluid intake and output. I will not talk about this subject too much because it's like something you do every day. We have something called daily water balance. Each day you take water from different resources like drinking from the food, and also water is produced inside your body. Those different ways of inputs, the total of them is like 2.6 liters. This 2.6 liters is going to be outside of your body by different output ways like insensible loss, sweat, feces and urine. So you have a balance between the input and the output of the water inside your body. We have also something called the daily salt balance. You take salts from different resources, mainly from ingestion, like 10.5 grams. Those total inputs is going to be outside of your body by different ways, like sweat, feces, and excretion in urine. Let's now talk about the compartments of body fluid. Inside our body, we have like 42 liters. We are talking about a male, okay, 70 kilogram adult, okay, because in females those numbers is going to be different, and in obese people they are going to be different, but mainly we are discussing an adult male 70 kilogram weight. Okay, so we have 40 liters inside our body. Those 40 liters are equal to 60% of our total body weight. TBW, it's the total body weight. Those 42 liters is going to be divided into two main compartments. The extracellular fluid and the intracellular fluid. The extracellular fluid will be 1/3 and the intracellular fluid will be 2/3. So 1/3 of 42 equals to 14 liters, and 2/3 of 42 equals to 28 liters. And in percentage, 1/3 of 60% is 20%, and 2/3 of 60% is 40%. So very simple. Those numbers are important to save, and we need to keep them in your mind. The extracellular fluid is divided into three main compartments. Okay, the interstitial fluid, the plasma, the transcellular fluid. The interstitial fluid equals to 3/4 of extracellular fluid, and it's like 10.5 liters. Those 10.5 liters are 1/4 of total body weight. So from 42 liters I have 10.5 interstitial fluid, and from those 42 liters I have 3 liters for the plasma. Okay, so the plasma equals to 1/12 of the total body weight. I know it's confusing, but by the time you will save them. So the plasma, it's like 3 liters from the extracellular fluid, which means 1/4 of the extracellular fluid, and 1/12 of the total body weight. The transcellular fluid is just 0.5 liters. They don't count it. And for example, for the transcellular fluid we have the synovial, the peritoneal, the pericardial, and the CSF, the cerebrospinal fluid, the fluid inside your spinal cord. For the plasma you need to have some information about it. It's the non-cellular part of the blood. Okay, when they want to calculate the plasma, they just take the blood, put it in a tube, centrifugation it, and after like a few hours the red blood cells will be aggregate in the bottom, and the plasma will remain in the tube. So they measure the plasma length. That's it. And we have a term, it's hematocrit. It's the bagged red cell volume. In the tube, the aggregation of the red blood cells in the bottom, they called it hematocrit. Okay, the fraction of blood composed of red blood cells, in men it's like 0.4, and in women it's like 0.36. This information is from the book. I just like to mention it. And lastly, let's move to the measurement of fluid volumes. There is different ways to measure the volume of the fluid inside your body. In the first lecture we talked only about one way. It's the indicator diluting principle. From its name we use an indicator. This indicator It's evenly distributed in target compartment, not metabolized, not excreted, and not toxic to your body. So it's easy to use. In the next lecture, we are going to talk more and more about the indicator. We are going to take this equation and we are going to talk about the second ways to measure the fluid inside your body. Okay, and thank you.